Next question on the exam asks you to write the column matrix B as a linear combination of columns of A. This is matrix A, and this is your matrix B. As you remember, you can form the augmented matrix and start reducing the rows, or you can reduce the columns. It doesn't matter which method you're using. But eventually, our goal was to form 1 and then 0, 0 on the first column, and on the second column, 1 as a pivot, and everything above and below 1 equal to 0. But in the process, you notice that, hey, you end up with a row with 0, 0, 0 that makes your calculations easier. Why is that? Because B, negative 22, 4, 32 can be written as 4 times the column negative 3, 3, 4 plus negative 2 times column 5, 4, negative 8. So what basically it is asked that, hey, if you have these 3 vectors, how can you write the linear combination of these to generate this first vector here? So in how many ways you can take this vector and write it as a linear combination of these two smaller vectors? So basically, we did that in our calculation. We found 2 unique values, 4 and negative 2, that help us to write this matrix negative 22, 4, 32, which is basically a vector, as a linear combination of negative 3, 3, 4, which is this column here, and the second column, which is basically another vector 5, 4, negative 8. So the linear combination of these two is equal to negative 22, 4, and 32. So we only have one linear combination. Now let's take a look at some of your work. One student wrote down, second equation and third equation become same line. The system has infinite combinations. So it's very difficult to analyze this line. Another student just left it as it is, 1, 0, 0, 0, 1, 0, 4, negative 2, and 0. There is no explanation. What's going on after this? How you did the conclusion? Another student wrote down x is equal to 4 and y is equal to negative 2. So we have infinite solutions. I'm not looking for the solutions. We're looking for linear combinations. And let's take a look at this. Again, you have 0, 0, many solutions. Many solutions for what? Are you talking about the solutions for the system? The system is consistent, inconsistent. And then you actually found 2 single values, unique values, that if you combine them, you get this. So how you have many combinations, or if you're referring to many combinations. It's a little bit difficult to follow the logic of students if you don't write anything, especially when it comes to linear algebra exam. Another student wrote down, as the last line is 0, it has infinite solutions. Another student wrote down, infinite solutions, there are more equations than variables. So if you write solutions or your work like this, you probably lost a couple of points. But again, please make sure to justify the work and read the question carefully. When it's asked about how many linear combinations, it's different from other types of questions that you might see. So you have just one linear combination. It basically, again, if you go back to the 3D graph, it's basically say, hey, you have this vector, you have 2 other vectors. How many linear combinations of these 2 vectors are possible to generate this larger vector here? So this is basically the question.